Know that there are planets outside of our solar system? They're called exoplanets. And 12 light years away from us, there's an exoplanet called Tau Ceti e. Tau Ceti is a rocky planet that is considered a super-Earth. It was first spotted in 2012, and NASA confirmed that it was an exoplanet in 2017. It follows the G-star Tau Ceti, which you can see with the naked eye.
Jingle, pay attention.
Here we have a photo of it. Over here is a photo of Tau Ceti e. It's, as clearly shown, a rocky and boring planet. Peak. Tau Ceti has an atmosphere similar to Earth. The planet is rockier and has more mass. It is slightly bigger than Earth. You would think that is a perfect backup plan in case we have to leave, but no. The planet is inhabitable, so we can't use it as a last resort because the mass is greater, meaning that it would be harder to move and we would be way heavier. The gravity would have a bigger gravitational pull than our Earth, making our bones collapse and our hearts strain, and then eventually we would explode. Cats, keep back and go. Peak. Not to mention, we haven't found a possible way to travel the speed of light. A light year is how much light can travel in a year. The fact that it's 12 light years, or 12 Earth years away, we would be dead by even something.
Dingle.
We believe is light traveling in a year, in a Earth year. The temperature of the planet is 3,200 Kelvin, or 53% of the sun. The star that Tau Ceti e revolves around is 0.45% luminosity. The reason that we use the luminosity that the star revolves around is because Tau Ceti doesn't have luminosity. If you're wondering what luminosity is the amount of radiation a solar object gets and how bright a star is. Over here is a graph of how you can measure luminosity. Red is the coldest. It's still gonna be hot. It's a star for crying out loud, but it's not the hottest star.
Okay, look at the shiny.
As you can see, you can measure it by different types of stars. Over here on this area is supergiants. Over here is main sequence stars. Over here are the giants, and over here are the tiny guys. A way that you can kind of like compare the temperatures of the stars is, think of how blue fire is much hotter than like regular like red fire to our eyesight at least. The weather of the planet would be like Earth's. The planet has an atmosphere, so that means it would have water and it would rain. But the amounts of water and hotness will be different because of the density and gravitational pull.
Jingle.
Yeah, birdcatchers. Tau Ceti has an atmosphere similar to Earth. The planet is rockier and has more mass. Speak louder! Over here is the luminosity, which is how they measure the luminosity. As you can see, the higher the luminosity, which is how they measure the luminosity. I can delete that part out, it's fine. But you're like, what? Red means hot, blue means cold. Well, in luminosity case, no it doesn't. And in this case, if you're wondering, why does red look like it's the smallest? If it's usually the hottest.
That they will be the last mistakes I ever made. Don't break them.